So before we can start talking about being able to do any proofs regarding sets and the operations with sets, we have to go through some fundamental definitions. So we're going to talk about some fundamental definitions of sets, elements, universes, intersections, unions, as well as set differences. So the first thing we talk about is the idea of a set. A set is any collection of elements, not necessarily numeric. An element or an observation is a single observation or a single item inside of the set. The universe is basically all the sets that we're considering. Alright, so it doesn't have to be every single element out there, but it's just what's in consideration. Sometimes it's called a population. Some of the operations on sets, for instance, if you want to have the intersection of two sets, that's all the elements shared between A and B. The union between two sets, all the elements in one set or another set. Set difference, all the sets that might exist in the first set but not in the second set. Okay. Complement, basically any set in the universe but not in the original set. Subset is true if all the elements that are within set A are also in set B. And then is an element of. So whenever you see this symbol, the is an element of A, that's true if that element is contained within A. So we have a number of questions that we're going to go through, and these are just questions that are based upon the idea of what is a set and then how to do some of the set operations. So the first one we have is A intersection B. So A intersection B, so if I look at set A, I notice that set A has 3, 4, 5, 6, and then I also notice that set B has 3, 4, 5, 6. I notice that set A does not contain 7, 8, 9, or 10. So set A intersect B is going to be 3, 4, 5, 6. Since those are the sets that are shared, or those are the elements that are shared between A and B. A union C. Basically what we're going to do is we're going to meld sets A and C, and any repeats we're just going to list it once. So I notice that set C has 1 and 2. I notice that set A has 3, 4, 5, 6. Notice that set C and set A have the element 5, but we only write it once. And then finally 10 is the other item that's contained in C. B minus A. B minus A essentially says that I'm going to take all the elements that are in A and I'm going to subtract them from B. So I notice that there's 3, 4, 5, 6 in A. I notice that there's 3, 4, 5, 6 in B. So what I'm going to do is I'm just going to get rid of those. That's what subtraction means. So we're just left with the set 7, 8, 9, 10. A minus C. So again, I start with A, and then any elements that are shared within A and C are subtracted. So I notice that there's a 5 that's shared between A and C. So what I'm going to do is I'm going to omit the 5, and I'm left with 3, 4, 6. B minus U. So I start with B. So B is fresh, so I'm going to get rid of this cross out. And what I'm going to do is I'm going to subtract any element that's in the universe. Well, we certainly know that the universe contains all of the elements in consideration. So B minus U is actually going to be the empty set. And there's two ways we can write the empty set. One of which is just going to be a set that contains nothing. Okay. Another way to write it that you guys have probably seen before is the 0 with a slash through it. Right, so another way to write it is just like that. Okay, you could just write one of the two, it doesn't matter. A intersect C, or I'm sorry, A complement C. Now A complement C is going to be all the elements that are contained in the universe but not contained in set A. So I look at A, I'm going to again cross that out, or get rid of the cross, and A complement is all the items in the universe, but not in set A. So I notice 3, 4, 5, 6. So what I'm going to do is I'm just going to copy the universe, and I'm going to get rid of 3, 4, 5, 6. And that's what a complement would be. All right, so again, everything in the universe, but not in set A. It's basically U minus A, might be another way to think about it. So if you think about that as U minus A, that's another way to think about how to figure out a complement. C complement. Again, what I'm going to do is start with the universe, and then I'm going to subtract out any of the elements that are in C. Alright, so I notice in C that we have 1, 2, 5, 10. So I'm going to cancel out 1 and 2. I'm going to cancel out 5. And then we'll cancel out 10. Alright. Finally, is A a subset of B? Why or why not? And the answer to that would be yes, because if we notice, if you look at A, all of the elements in set A are contained within set B. Alright, so we would say yes, all elements in set A are also contained within set B. Alright. And then finally, is B a subset of A? Well, we can find exactly one. In fact, we can find more than one. But as long as you can find one element that's in set B that's not contained within set A, then you can say it is not a subset. So we can say no. An example of an element in B that is not in A would be x equals 8. All right. So those are just some fundamental definitions of some operations on sets. The next section, what we're going to do is we're going to take a look at some of the subsets, but before that, make sure you're okay going through answering these types of questions before you move on to the next section.